Welcome to another coding tutorial, and in today's video I'm going to show you how to create string art. So what is string art? I've heard people call it string art or thread art. It is a technique where patterns or images are created by winding a piece of string or a thread around a set of fixed points, usually nails or pins on a board. And talking about string art, we cannot not talk about the artist named Petros Varoulis, who really brought this technique to life by using algorithms to find the most efficient way to connect points on a circular frame. And he has made many beautiful work, which we will try to create today using an algorithm called the greedy algorithm. So what is the greedy algorithm? The greedy algorithm is a simple approach of solving problems by making the best possible choice at the current steps without worrying about the future steps, which I also believe is a great way of approaching life. It doesn't look ahead to see if a different choice might be better later. It just picks what is best at the current moment. And even though this method might not find the best possible solution, it quickly finds one that is close to the best overall result. And here are the steps that we're going to follow to create the string art. First, we start by preparing the base image, and we do that by converting the input image into grayscale. And after that, we then define the circular frames, and we do this by placing evenly spaced points or nails around a circle to serve as anchor points for the thread. After we set all of this up, we start using the greedy algorithms to find the best possible paths. And as I mentioned before, the greedy algorithm focuses on finding a solution for the current step. We do this by looking at the current nail position and evaluate all the possible connections between that particular nail to all of the other nails around the frame and find the one that provides the highest contrast, and that is because the darker areas need more thread, so the algorithms prioritizes connections that increase contrast the most. And once that solution is found, then we move to the next point, and then we repeat the process over and over again. And lastly, in each step, we need to update the image to reflect the change. Each new thread reduces brightness along its path, and the algorithm then evaluates contrast based on the modified image rather than the original. And after we repeat this process over and over again, thousands of times, then we get the pattern that we want. All right, we're gonna start by uploading an image, and we can do that by coming to this arrow here, click the plus sign, and then click upload file. And then you want to drag and drop your file in here. Some images will provide a better result in terms of the thread art than others, so be sure to play around with the type of image that you put in. And then once your image is uploaded, what you want to do is you want to first create a variable. I'm gonna call mine img for image. And then we're gonna write a function called preload, and this will allow us to preload the image onto the sketch. And I'm going to set the variable image img to be equals to another function called load image. And the argument that we want to put in here is where the image is, and it basically is in this directory. So we can just put in the name of the file. So put it inside a quotation mark. My photo is a photo of Einstein, so it's Einstein.png. And then let's click run to make sure that everything works okay. And it is. All right, so next what we're gonna do is inside draw, I'm going to use a function called image to actually draw the image onto the sketch. And we need to provide 3 arguments. The first one is the name of the file, and then the second and third are the x and y coordinates of the top left corner of the image. So let's do 0, 0. All right, and as you can see, the image actually is slightly bigger than the canvas. Actually, my image is of the size 500 by 500, but if you want it to fit exactly onto here, you can actually just put in the 4th and the 5th argument as the width and the height. So I could do 400 by 400. But as I mentioned in the steps to create the string art, we want to prep the image by first actually resizing it and then actually make it grayscale. And as you can see, actually the image, my image is already in the grayscale, but let's just do that. So I'm going to delete this and then click run again, just to show you that the image is actually bigger. And then inside setup, we can resize by putting img, the name of the file, dot resize, and then you want to provide two arguments, which are going to be the new width and the new height. So how about I also actually set a variable for the canvas size, because we want to also play around with that. So let's do canvas size to be equals to 400. And then we can put in canvas size here. And I'm actually going to copy and paste this inside here. I'm going to make this image in the grayscale, but because mine is already gray, you will not see any difference. But what you want to do is you want to put in img.filter, and then you want to put in an argument gray. Let's click run again. Now I want to store all of the pixels of this image inside an array. But to do that, first we need to get the pixels information, and we can do that by writing img.loadPixels. Then after that, what I'm going to do is I'm going to create another variable called imgPixels, and it's going to be an array. What I'm trying to do is that instead of changing the values inside the original image, I want to actually copy the pixel values inside this image pixels array. And what we need to do is that we just need to set this imgPixels to be equals to img.pixels. And then to copy it, we use the method called slice. And now how about we print out, I'm not going to print out actually the array because there are actually so many values, but I'm going to show you how big it is. So image pixels.length, and then also img.pixels.length. And it has a total of 640,000 values. And you might be wondering why, because the canvas size is 400, and 400 times 400 is 16,000, right? 162040. No, it's 160,000. But the reason that it has the length of 640,000 is because in each of the pixel, there are a total of 4 values: red, green, blue, and alpha. So in each pixel, it has 4 values, and 160,000 times 4 is 640,000. All right, and that's why I don't want to print the array out, because it's going to crash our program. Next, we're going to be creating the circular frame by evenly spaced out the nails around it. So why don't we start by creating a few variables. Let's do an array called nails, and then nail count. Let's do, how about 100 nails? And let's just start with that. So inside setup here, I'm going to write a for loop that goes from I equals to 0 to I less than nail count, and then I plus plus. And what we're going to do is that we're going to get the X and Y coordinate positions that evenly spaced out all the nails around a circle. So we need to calculate angle. So angle will be 2 pi, which is 1 circumference, divided by nail count, the number of nail, and then times I. And this gives us the angle that will evenly spaced out the nails. And then now we are going to use this angle position to find the X and Y coordinates by using cosine and sine. So X will be equals to the radius r times cosine of angle, and then y to be equals to r times sine of angle. And then what should r be? So how about I want it to be almost the size of the canvas. So r will be canvas divided size divided by 2. And then I'm actually going to subtract a little bit of a margin so it's not completely at the border of the canvas. So let's do minus margin. And how about we set margin to be, let's do 10. Now we have, okay, so now we have X and Y. So we're going to push these values inside the nails array, right? So we want to populate it, and we can do it using the function push. And we're going to push a vector, and a vector is an object that can hold 2 to 3 values, and we're going to use a vector to hold two values, x and y coordinates, and we can create a new vector using a function, a method create vector, and then x and y. All right, and inside draw, how about we just draw out these points? So we just loop through the same thing, and then we're gonna draw an ellipse at nails of I dot x, nails of I dot y, and then let's also provide nail size as a variable. Let's do nail size to be equals to 2. How about that? Okay, let's try this. All right, so the reason that you only see a quarter of a circle here is because the origin point is at this point right here at the top left corner. So we want to move everything out by canvas size divided by 2 plus, and same for y. All right, and if I subtract a little bit bigger for the margin here, let's do 50. Okay, you get the point. You can play around with these values. I'm actually going to do a canvas size of 300, so let's make it a little bit smaller, and then let's do 30 here. What we want to do is we want to create another array. Let's call it line index, and this is going to be the index or the position that we're going to be looping or winding the thread around. Okay, let's start by creating the array. Let's call it line index, and then we need to pick the first point, and I'm going to do it randomly. So inside setup here, we're going to do let starting index, and we're going to randomize it between the length of the nails, right, which is going to be nail count. And because we use random, it will return a decimal value, so we want to also use floor to get the closest integer. And then after that, we're going to add this point inside the line index array, starting index. And okay, so let's just print line index. So now we have 61, 42. So we get a random value, and then the length of the line index array is just 1. Okay, so now how about we start drawing the line? So let's do another for loop. This time it goes from I equals to 0 to I less than the line index length, right? I plus plus. And actually, we're gonna be deleting this after, but I want to also add another point. So let's do line index dot push. How about starting index plus, let's do 10. So this way we can actually see a line. And we're gonna define two variables. These are gonna be the two nail locations, right? So let's do, how about nail 1, and nail 1 is going to be nails of that index, right? So actually, instead of doing I starting at 0, I'm actually going to start at 1, and here I'm going to do I minus 1, and then nail 2 will be nails of I. So the nails array gives us the x and y coordinates of the nail's position, but the line index gives us the index of which nail we're gonna pick, right? So now we're gonna use a function called line to draw all of these points out. So it's gonna be nail 1.x, nail 1.y, and then nail 2.x, nail 2.y. And let's click run. Okay, you can see, oh, I did this wrong. Okay, so it should actually be from one point, and then another point or another nail should be 10, the length of 10, right, apart because of this. But what I'm doing right now, it's nails of 0 and 1 basically. So actually it has to be nails of line index of this, right? And then same thing here, line index, because line index give us the value that is these two values here. And let's click run again. It gives us an error, I think, because the first one might be greater than the length. Let's try again. It's okay. All right, so now you see it gives me an error because I think the random index here is within the range of the nails, but then plus 10 might be greater. But if we keep clicking, it will work. All right, so we see that we can draw the line. Next, we're going to be using the greedy algorithm to find the best path for that particular nail at the current moment. We're going to define another variable, let's call it max lines. So this is going to be the number of iterations that we're going to do. We're going to set a limit. So we're going to write a conditional statement that says if line index.length is less than max lines, then we're going to be doing this algorithm, the greedy algorithm. Else, then how about we print out max lines reached, and then we're going to stop. And so we're going to use the function called no loop, which basically going to stop the draw loop from running. And we also want to define max lines. Let's start with 1,000. And then now in here, if it is less, then what we want to do is that we're going to be evaluating the contrast between all of the possible paths, which is from the current nail to all the nails that are not that one, right? So how about we first defined, how about current nail index? And this is going to be the very last index inside the line index. All right, so line index of line index.length -1, right? Because we keep adding the index at the very end of the line index array. Then next nail index will be set to a function. We're going to be writing a new function to use the greedy algorithm. So how about we call it find next nail index, and the argument that we're going to put in is actually the current nail index, and this function is going to return the next nail index for us. So before we go and write that, I want to keep going. So once we have that, we're going to say that if next nail index is not null, so it returns a value, then what we want to do is that we want to add that to the line index array, right? So line index push next nail index, and then after that we also want to update the image, right? So we're going to update it by decreasing the brightness as if the thread is already there. And once we update the image, we're going to use that image to evaluate the contrast in the next iteration. So I'm just going to leave it as update image. I'm actually going to comment it out too. But if it does return null, then we know that we cannot keep going anymore. So we're going to print no valid nail found, stopping. How about that? And then we're going to do the same thing. So no loop. Okay. And now if I click run, it's going to give me an error, and that is because we have not written find next nail index yet. So let's do that. So function find next nail index, and we're providing the current index, right? Current index. I'm going to set two variables. So we're going to set one called next index, and we're going to start it with a value of null. So if all of the stuff that we are evaluating doesn't actually result in anything, the value will be null. And then I'm going to set another value called highest contrast and set it to 1. So basically what we're going to do is we're going to evaluate all the lines that connects the particular current index to all of these other nails. And we're going to evaluate the contrast, and then we're going to check which one has the highest contrast, and we're going to pick that particular index as the next index. So let's do a for loop that goes from let I equals to 0 to I less than nails.length, I plus plus. Then we're going to first check that if I is not equals to current index, right? We don't want to do the one. We want to make sure that all the ones that we are evaluating are the ones that are not of the current index. Then we're going to set contrast to another function. Let's call it evaluate contrast. And we need to give 2 points, right? The current nail and then the next nail. And how about we call it nail 1 and nail 2. And then this is going to return some contrast value. We will be writing the evaluate contrast function next, but what we want to say is if contrast, if this value that is returned back is greater than highest contrast, then we're going to set highest contrast to contrast, right? And we keep doing this until we find the highest one, and then we're also setting next index to be I. And then outside here, honestly, we don't want to return null, right? If we return null prematurely, it's going to stop very quickly, right? No valid nail found, stopping. So what we're going to do is actually we're going to pick some random points. So if next index is equals to null, then we're gonna randomly pick an index. So let's do next index equals to random of nail count, right? And we also need to put in floor. And how about we also print finding random next index, just to see how often this actually happens. Okay, and at the very end, we need to make sure that we return next index. And next index is gonna be returned to here, right? And then once we have current nail index and then next nail index here, then we push it into the lined index. Okay, I cannot show you if my code is correct yet because we also need to write evaluate contrast. So let's just try that. Maybe if I click run just to make sure that there's, so we need to write evaluate contrast. So let's do that. So function evaluate contrast. So we want to provide what? Inside here, we want to provide 2 nails, right? The location of 2 points. So let's do, actually here, instead of nail 1 and nail 2, we actually want to put, current index and next index, right? And then here, let's do I1 and I2 for current index and next index. But then because we're going to be finding the contrast between 2 points, we're going to look at all of the pixels, not all, but you'll see the pixels underneath the path. So we want to actually first get the location, right? So nail 1 will be nails of I1, and then nail 2 will be nails of I2. Instead of sampling all of the paths or all of the pixels underneath the line, we can choose how many we want to do. And I'm going to define a variable called steps. So let's do steps to be equals to, how about we start with 100? And you can change this variable too, and that might give different contrast values. So what we're going to do is we're going to go through the steps. So I equals to 0, so I less than steps, I plus plus. And we're going to be using linear interpolation, and the function that we're going to use is called lerp, and lerp basically finds the intermediate points between 2 points. So what we need to do is we want to find the x and y coordinate, right, between, let's say, these two lines here, 100 of them. So x will be equals to lerp, and it is going to be interpolating between this point here and then this point here. So it's going to be nail1 dot x and then nail2 dot x. And we want to find all the points. So it's going to be I divided by steps. This basically gives us like between these 2 points, where along the points do we want? So it's going to start with 0 divided by 100, which is 0. And then the next one is 1 divided by 100, and so on and so on, right? And we're going to do the same thing for y. Lerp nail1 dot y, nail2 dot y, and then I divided by steps. All right, and I forgot to actually create another variable called total contrast, because we're gonna actually, let's begin it at contrast. We're gonna start with 0, and then we're basically going to get the pixel value underneath all of these points, 100 points, and then we're gonna add it to the total contrast variable. So now we want to get the pixel values, right? So what we have to do is, first we're actually going to create a conditional statement that says, that makes sure that like the pixel is actually underneath the, inside the canvas. So x is greater or equals to 0, and x is less than canvas size, and y is greater or equals to 0, and y is less than canvas size. This is honestly is just for precaution. And then we're gonna create pixel index. So first we want to find the index, right? And remember at the very beginning I told you that one particular index has actually 4 values, R, G, B, and A. So we need to find the pixel index, and by having these x and y values, we can turn it into pixel index using this function, 4 times y times canvas size plus x. Because the values inside the pixel index, inside the image index, image pixels array is a 1D array. And for us to be able to get the right location, the right index, we need to use this equation. Then once we have this, we want to evaluate what is the brightness, right? So let's do brightness to be equals to image pixels of pixel index. And this is why we actually turn the image into gray or grayscale, because we can get the brightness, which ranges between 0 and 255. And then now it's time for us to add it to the total contrast variable here. And we can just add brightness, but we will not. And that is because the brightest value for us, or the highest contrast, is when it's black, right? But the black value in this case is going to be 0. And the least contrast, which is white, has a value of 255. So what we want to do is that we want to do 255 minus brightness here, so that when it is the highest contrast, which is black, and this brightness value is 0, then we get the value of 255. And now outside of this for loop, we're going to return. We can just return total contrast, but what we're going to do is we're actually going to do total contrast divided by steps. And that is because the total contrast value will not be depending on how many steps that we use to cut up this line of thread. All right, that was a lot of writing, and we have not actually checked if it's correct. I'm just gonna run and see what happens. $94. Oh, okay. So we also need to put the word floor, right? Because these are basically returning a decimal value, and we need an index value to get these. Okay, what else is wrong here?
A few moments later.
Oh, okay. So, all right. First thing first, I spelled contrast wrong in many places. And I've already fixed that. But here, we are evaluating what? The current index, which is the current nailed, and all of them, right? Not next index here. It has to be I. Or I actually have not checked this, but I think that is what I did wrong. And also up here, I forgot that I need to delete this line too. Let's try that. Okay, works now, but it only gives us a few of these lines, and that is because we also need to write the update image here. And okay, perfect. Let's do that. So the update image will have two variables also, two arguments. So let's do current nail index and next nail index. Okay. And then down here, we're going to write the function called update image, and we're going to put in the parameters as same thing here, I1 and I2. Actually, the steps are quite similar to the evaluate contrast function. We're going to start by creating two variables for the nail 1 and nail 2, which is going to be nails of I1, and nail 2 will be nails of I2. We are also going to create a variable called steps because we're going to be stepping through all the pixels underneath that line. So what we're going to do in the update image is basically we're going to decrease the brightness of that particular area that we have drawn the thread, right? So let's just do the for loop that goes from I equals to 0 to I less than steps, I plus plus. And similar to this, we're going to be writing or finding the x and y coordinates using the lerp function. Same thing here. And now we're going to also find the pixel index using the same function. So let pixel index be equals to 4 times y times canvas size plus x. Then now what we're going to do is that we're going to be updating all of the pixels underneath that line that we choose. So let's do another conditional statement. If pixel index is greater or equals to 0 and pixel index is less than image pixels dot length minus 3, right? Because we have 4 values. This is just to make sure that the pixel that we are changing inside the image pixels array is within the index value. So we're basically going to change the values, the brightness value. So what we're going to do is we're going to change the values of the pixels inside the image pixels array. So we're going to do image pixels of pixel index to be equals to image pixels of pixel index plus 10. How about we add it by 10 values each time? And actually, because the brightness will go up to 255, I also want to write another conditional statement that says if image pixels of pixel index is less than, actually let's do 255 minus, how about we create a variable called bright, and instead of this hard-coded value of 10, and then let's do let bright equals to 10. Then we change the values of pixels index, and this is the red value, right? So we actually want to do 2 more. So this is 0, pixel index plus 0 plus 1 and plus 2. So we get the red, green, and blue. And then after we change this, then basically the image pixels array is already changed and it should work now. Let's click run. Nice. But what I'm gonna also do is I'm going to change the original image pixel. So we can do img.pixels.set, and I'll show you why I want to do this. We're gonna set it to the array image pixels, and then after we update this, we also need to do img.update pixels. And as you can see before, the lines are super thick. So how about up here inside draw, let's do no fill, and let's do stroke of the color black, but let's do transparency of, how about 60, and then let's do a smaller stroke weight of 0.5. Nice. And the reason that I wanted to update the original pixels here of the original image is so that we can actually put it side by side. So let's do, first we need to change the canvas size for the width to be canvas size times 2, and then I'm going to put this image at canvas size, comma 0. Right? Yeah. Let's try that. Now you can see the white lines on his face here as we draw on the left side. And now we just need to wait. Oh, max lines reached. How about we do 5,000? All right, I'm gonna stop here, but as you can see, the image it doesn't look that great, and I think there are different variables that you can play around with, whether it be canvas size, the margin here, the number of nail count, the max lines that you want to use, and also stroke weight, stroke color. You can play around, but the last thing I want to show you is that we can actually save all of the locations in a text file, right? So that if you want to do a physical, actual threading of these, like winding these threads around nails, so you have the direction. So where we have all these no loop, I'm going to save a text file, which is already, the locations are stored in the line index array, right? So we need to provide, the first value is the line index, and then we just put in the name. So let's do thread path.txt, and we're going to do the same here as well. And how about I change the nail size to, let's do 200. Let's do a smaller canvas size and do margin of 10. And also let's change max lines to 1000. Okay, so you get the gist. The 1000 max line is too small, but I just want to show you that now you get this text file that shows you all the position of the nails that needs to be connected together to create the path that you see here. So I think this is a really fun one where you basically merge between the digital and the physical world, and I hope that you can find inspiration from this and maybe create your own string art, and let me know. Give this one a try.